Hello friends, comrades, fellow creatures of life. This is going to be on the philosophy playlist. In particular, these next couple videos will mention several brief pre-Socratic philosophers of the world of classical antiquity. In particular, we will go over such writers as, I'm skipping over Thales for a while. I've talked about Socrates, and I've talked about Plato and Aristotle. I've read all of Plato, not all of Aristotle, obviously, but Aristotle's pretty thick to get through. But the pre-Socratic philosophers of classical antiquity, we have in our first reading, we have Anaximander, Anaximenes, and Pythagoras, which I've read in other histories of philosophy, but in particular, this is A.C. Grayling's History of Philosophy. It's the next best history of philosophy after Bertrand Russell. We'll go over, in the reading 2, Xenophanes, Heraclitus, and Parmenides. And in reading 3, we will go over Zeno of Elea, Empedocles, and Anaxagoras. Then in our fourth reading, we will go over Leucippus, Democritus, and the Sophists. So, sit back, enjoy the video on Anaximander, Anaximenes, and Pythagoras. Alright, as you can see, I've read this entire book. Alright, so all the philosophers, and I'm going to go over some other more modern philosophers, not too many of those, some modern philosophers, but mostly some contemporary philosophers that I think are really important for us to grasp for our time. This is The History of Philosophy by A.C. Grayling. And then he also goes over not just continental analytical philosophers, but he also goes over ancient, medieval, modern, and contemporary philosophers in continental philosophy. And then he also goes over some Indian philosophy, some Chinese philosophy, Arabic Persian philosophy, and then even the very small, loosely formed philosophy of African philosophy. So, alright, so Anaximander, Thales' people. Alright, I'm skipping over Thales, not because I don't like Thales, but because for some reason, I just don't want to mention Thales. I don't know why, but anyways, Thales was the first philosopher. But anyways, Thales' pupil Anaximander rather startlingly fast-forwards the concept of arche, saying that it is the apeiron, the unbounded, or indefinite, or infinite. This is a remarkable leap from the idea that arche must consist of some form of matter. Unlike his teacher Thales, Anaximander wrote a book titled On Nature, Periphuseus, and a quotation from it by Simplicius counts as the very first recorded words of philosophy. Like all the early philosophers, Anaximander was a man of many abilities. He is credited with being the first person to draw a map of the entire world, as the world was then thought to be, and is said to have predicted an earthquake. The ability to foresee awesome natural phenomena, Thales had his eclipse, seems to have been a mark of genius attributed by later writers, for whereas eclipses might with difficulty have been predictable in those days, the ability to predict earthquakes is still so far largely beyond science. Anaximander was said by Eusebius to have developed gnomons for identifying solstices, time spans, hours, and equinoxes. Modern scholarship suggests that what he made was a sundial for making the seasons, not the hours of the day. Apparently no sundial for telling the time of day has been recorded as existing before the year 350 BCE. But anyways, what hours meant to Anaximander was both hours and seasons. Diogenes reports that Anaximander erected a gnomon in Sparta, or a sun, as it suggests, he traveled He is said, among other things, to have been involved in establishing a Milesian colony on the shores of the Black Sea. Anaximander thought that humans came originally from fish, which looks like an anticipation for evolutionary theory, but to think so would be to read in present ideas to what superficially sounds suggestive in ancient ideas. However, he thought that we came from fish, and this was a very revolutionary idea for his time. In any case, he said we should not eat fish on the grounds that they are our kin. Evolution tells us that all living things are kin. Humans share a quarter of their genes with rice, so on Anaximander's view, we should not eat anything. He said that the sun is pure fire and is not, as most people appear to have then believed, smaller than the earth. He said that the moon shines by reflecting light from the sun, and that rain comes from vapors that rise and condense into clouds. He attempted calculations of the relative sizes of the sun, moon, and earth, and said that the earth is cylindrical. It is a short, fat cylinder, and the upper flat end is where we live, surrounded by an ocean. Diogenes, however, says that he thought the earth is spherical. In either case, the earth hangs motionless in the midst of the infinite, having no more reason to fall than to rise, or indeed to move in any direction at all. Anaximander's most distinctive thesis, however, concerns the arche. He said that the apeiron, the infinite, or the indefinite, is that from which everything comes into being, and into which everything finally reverts, by a process which is like reciprocity or compensation. Those famous first ever words of philosophy, as quoted by Simplicius, express this idea. Quote, "Where things have their origin, their passing away occurs according to a necessity. They pay justice and reparation to one another for their injustice in conformity with the ordinance of time." End quote. The concept at work is that nature operates according to laws, and when they are disturbed, reparation sets in to restore their proper operation. When justice is interpreted as balance, the point becomes yet clearer. His view is reported at more length by Plutarch, thus, quote, "The infinite is the universal cause of the generation and destruction of the universe. From it, the heavens were separated off, and in general all the worlds infinite in number." He asserted that destruction and much earlier generation occurred from time immemorial, all the same things being renewed. End quote. The reasoning behind Anaximander's view is suggested by Aristotle in the Physics, where he discusses why it might be held that the infinite is the principle of things. First, he notes that the infinite can have no other purpose than to be a principle, and can itself have no principle, that is, cannot derive from anything more fundamental than itself, for if it did, it would not be a principle. The idea of the infinite is attractive, Aristotle remarks, when we think of the nature of time, and also of mathematics. Moreover, it is held that the region outside the heavens is infinite. Then body and worlds also seem to be infinite. For why should there be here rather than there in the void? If body is anywhere, then it is everywhere. Again, if void and space are infinite, body too must be infinite. For with internal things there is no difference between being possible and being actual. And Aristotle then identifies a consideration that might relate more closely to Anaximander's view, that generation and destruction will come to an end unless there is something infinite from which what comes into being is subtracted. The range of Anaximander's interest is impressive, as is the nature of his thinking. His ideas are imaginative and striking, from drawing a map of the world to measuring time and the seasons and the relative sizes of the sun and moon, to conceiving of nature's laws and their balance, of a plurality of worlds, and finally of the cosmos itself as emerging from the infinite. All this indicates a gifted and ingenious mind. Among the early Ionian philosophers, he is the most imaginative. Martin Heidegger, which we will have a lecture on later, Martin Heidegger lectured and wrote on Anaximander, on the Anaximander fragment in Simplicius, the Anaximander fragment. This was in 1946, the year after World War II ended. Now we go to Anaximenes. As one of the might expect from a pupil of younger colleague of Anaximander, Anaximenes learned from both his predecessors. He agreed with Anaximander that the arche is apeiron, infinite, but he did not agree that it was indeterminate. Rather, he agreed with Thales in thinking that it was material, but he identified a different material candidate. with what he took to be greater metamorphic capacities than water, and therefore better able to be the source of the variety of things in the world. His candidate was air, all right, but a sort of dense, moist air or vapor. Thales thought everything in the world was eventually composed of water. And now Anaximenes is saying that it's really air or vapor. So given his view is given in Epitome by Simplicius, quoting Theophrastus. Anaximenes, like Anaximander, declared that the underlying nature is one and unlimited but not indeterminate, as Anaximander held, but definite, saying that it is air. It differs in rarity and density according to the substance it becomes. Becoming finer, it turns to fire. When condensed, it comes to be wind. Then cloud, and then when further condensed, it becomes water, then earth, then stones, and the rest come to be from these. He makes motion eternal, and says that change also comes to be through the eternal motion of the air. Note that this last point provides a basis for motion and change without the need to suppose that things have little souls in them. Anaximenes held that the earth is flat and sits on the air like a lid. Thus Aristotle describes this view. His theory allowed him to say that cloud is thickened, moist air, that when it is squeezed, rain falls from it, which becomes hail when the water freezes, or snow when there is an admixture of wind in the moisture. Earthquakes occur when the earth is either too dry or too wet, for when too dry it cracks, when too wet it falls apart. The sun, moon, and stars are air refined into fire. They too are flat and ride upon the air. The stars too are too distant for us to feel their heat. The sun does not circle underneath the earth to reappear at dawn, but instead rides around the circumference of the flat earth, rather as one can make one's hat revolve on one's head. It is hidden from us by distance and mountains as it makes its passage back to the starting point, which is why the night is dark. A significant point of interest is Anaximenes' concept of condensation and refraction as the mechanism of the transformations that air undergoes. Thales did not offer a suggestion about how his arche could change from liquid to solid and gas, but Anaximenes does. Moreover, Anaximenes regarded heat and cold as properties of air, not as substances in their own right. Plutarch writes, as Anaximenes of old believed, let us have neither the cold nor the hot in the category of substance, but as common attributes of matter, which come as the results of its changes. For he declares that the contracted state of matter and the condensed state is cold, whereas what is fine and loose, calling it this way with this very word, is hot. As a result, he claimed that it is not said unreasonably that a person releases both hot and cold from his mouth, for the breath becomes cold when compressed and condensed by the lips, and when the mouth is relaxed, the escaping breath becomes warm because of rareness. The observation that air blown through pressed together lips is cool, but warm when exhaled from open mouth, is verifiable. One can do this simple experiment and feel the proof on the back of one's hand. This shows that Anaximenes' views were attempts to make sense of observation, and this is the significant point, doing so in a systematic, inclusive theory that brought all phenomena together into a single explanatory framework constrained by those observable facts. The resources, both conceptual and practical, for devising such a framework were primitive. These thinkers were starting from scratch. Only makes one admire them more. Next, in historical order, is Pythagoras, but he is personally something of a mystery. There was certainly a Pythagorean school or cult, perhaps a religious order, that had something to do with a charismatic individual called Pythagoras, and the contribution of his order to mathematics and related subjects is very considerable. Its teachings influenced Plato, who however mentions the individual in Pythagoras only once by name, saying that his followers were profoundly devoted to him. The remark occurs in Book 10 of Plato's Republic. His disciples loved him for his teaching. Even now, his latter-day followers stand out for their manner of life. Aristotle mentions him only twice in his extant works, but wrote a book on his school which has been lost. Quotations from it in latter sources suggest that Aristotle wrote chiefly about the religious aspects of Pythagoreanism. Indeed, the stories associated with the individual Pythagoras tend mainly to appear in the latter doxographical tradition, by that time relying on legends and mystical traditions of a dubious kind. The earliest references to Pythagoras occurs in verses by Xenophanes, which relate that Pythagoras stopped a man from beating a dog because he heard the voice of a deceased friend in the dog's howling. This conforms with the Pythagorean doctrine of metempsychosis, that is, the transmigration and reincarnation of souls. Pythagoras is said to have forbidden his followers to eat beans because they contain the souls of the dead. Another early reference to Pythagoras is found in a fragment of Heraclitus' work. Heraclitus, who lived just a generation after Pythagoras, praised the advances he had made in science, but said that he had misused them for charlatanry. Charlatanry, yes. This lends credence to the idea that the Pythagorean group was more than a philosophical school, being dedicated to a religious way of life also. By origin, Pythagoras was an Ionian. We give him a birth year of 532 BCE. My mistake. 570 BCE. He was born at Samos, an island close to the Ionian coast between Ephesus and Miletus, during the reign of Pythagoras, and is said to have left Ionia for the city of Croton in Italy in order to escape Polycrates' tyrannical rule. This detail is implausible. Other sources say that he undertook diplomatic missions at Polycrates' behest. In any case, the court of Polycrates has been regarded as an enlightened one, at which the poet Anacreon and the famous engineer Eupolemus of Megara lived. Whatever prompted Pythagoras' idea to leave Samos, legend has it that he first traveled widely in Egypt and the East before settling in Croton. And hagiographers credit some of the doctrines associated with him to his studies there. It is something of a reflex among doxographers to credit several of the early Greek thinkers with acquisition of wisdom from the East. The belief that the East is a source of especially deep wisdom persists into our own day still. It seems that the religious aspect of Pythagoreanism was focused on worship of the god Apollo. For a time, the older wielded considerable political influence in the Greek cities of southeastern Italy, but lost its influence in an uprising that followed Croton's destruction of the city of Sybaris in 510 BCE. A follower of Pythagoras, a famous champion wrestler called Milo, who led the Crotonites in their victory over the Sybarites, was burned to death with other Pythagoreans in their lodge when the citizens of Croton rose against them, thinking that Milo intended to impose a dictatorship on them. Only 2 members escaped. In Diogenes' account, Pythagoras himself was present in the house when it was attacked and attempted to flee, but he was captured when he found himself at the edge of a bean field, which he would not cross because of his scruples. And so, says Diogenes, his pursuers cut his throat. Other lodges in other cities were burned down also, the cohesion of the order being thus destroyed and its survivors dispersed. Neither Plato nor Aristotle quotes any sayings of Pythagoras, and much of what is claimed to be reports of his teachings has turned out to be forgery. What is at least certain is that the Pythagoreans believed in metempsychosis and were vegetarians, though, as we have seen, they avoided beans. On the basis that animals and humans are kin, and to eat flesh is a kind of cannibalism. Indeed, some of the teachings ascribed to Pythagoreans, especially the things heard, or the acousmata, that is, the symbolic rulers of the order, suggesting a survival from concepts of taboo. They include prescriptions against breaking bread, stepping over crossbars, touching white cockerels, walking on highways, letting swallows live in the roof of your house, and looking at yourself in a mirror next to a light. Pythagoreans were instructed to roll up their bedclothes when they got up in the morning and to smooth out the impress of their bodies on the mattress. It is unfortunate for our understanding of the philosophy of Pythagoras that the legends which grew around him centuries after his time obscure how much influence he had on Plato and others. In the text of the Neoplatonist philosopher Porphyry and Iamblichus, writings much later in the 3rd and 4th century CE, he is represented as a prophet-like holy man who had received divine revelations. Iamblichus calls him the divine Pythagoras in his treatise on the Pythagorean life, and Porphyry says no one else has had greater or more extraordinary things believed about them in his life of Pythagoras. Some of these views led to the theory that much of Plato's own thought is borrowed from Pythagoras. It would be easy to think that Pythagoreanism is just another of many cults and movements predicated on primitive beliefs, but the school's contribution to mathematics and science make it unignorable. Indeed, even among the more cult-like aspects, there are points of interest. Pythagoreans believed that music purifies the soul, and point for a belief system seeking to help the soul escape from the wheel of rebirth, as was the aim also of Orphism and other mystical cults. Moreover, Pythagoreans divided people into three kinds. On analogy with people who attended the games, some come to compete, and some come to buy and sell under the stands, and some to spectate, for which the Greek verb is from which we get the word theory. The philosophers are those who spectate or look upon the world to study it. These latter are the best kinds of people, therefore, said the Pythagoreans, and closest to purification and consequently to escaping from the cycle of rebirth. The mathematician Aristoxenos said that Pythagoras was the first to take the study of arithmetic beyond the practical needs of commerce. The Pythagoreans introduced the way of representing numbers by arrangements of dots and triangles, squares and rectangles, and demonstrated a number of arithmetical properties through the geometries of these arrangements. The number shapes had religious significance too. The one by which Pythagoreans swore their oaths was the triangle, or the triangle of dots with the row of 4 along the bottom, 3 above that, then 2, then 1, adding up to 10. Pythagoreans thought that 10 is the natural basis of counting, and gave it a mystical significance. There is, of course, an infinity of triangular numbers. 3 is represented as a triangle of 2 dots with 1 dot above it. 6 is represented as a triangle of dots arranged 2, 3, 1. 10 we have seen. 15 is 5, 4, 3, 2, 1. And so on. Rows and columns are the same number of dots as each other give square numbers, while oblong numbers are those in which the rows have 1 less dot than the columns. We now use numerals ultimately derived from India, though now called Arabic numerals, because the Arabs transmitted them to the world at large, but we still often call numbers figures. If there is one thing almost everyone knows about the Pythagoreans, it is Pythagoras' theorem, stating that the square of an hypotenuse, this being the longest side of a right-angled triangle, opposite the right angle itself, is equal to the sum of the squares on the other two sides, where a is the hypotenuse, a squared equals b squared plus c squared. This was in fact known to Thales, to Egyptians in the geometry of land mensuration, and to Babylonians and Indians long beforehand, but it is possible that Pythagoras or a follower discovered a proof. A major achievement of the Pythagorean school was the discovery that the pitch of a musical note depends on the length of a string whose vibration produces the note, and that simple numerical ratios explain the consonant intervals of the scale: 2 to 1, octave; 3 to 2, perfect pitch; 4 to 3, perfect fourth, and so on. To understand this, think of 2 guitar strings of equal length, tension, and thickness. If they are both plucked together, they sound the same. If different lengths of each are plucked, they sometimes sound dissonant and sometimes consonant. This latter observation underlies measurement of consonant intervals, an interval being the distance between 2 notes, and a consonant interval between being one in which the 2 notes sound good together. Experiment will show that if you have 2 lengths of string of equal length, tension, and thickness, plucking one while simultaneously plucking exactly half the length of the other will yield a consonance. This is the octave. If the second string is plucked at 2/5 the length of the first, the resulting consonant is a perfect fifth. Go to a piano and play the notes middle C and G above the middle C together. That is a perfect fifth. This discovery, even more than the theorem about the square on a hypotenuse, has been held as the first step of true science because it provides a quantified description of an observable phenomenon, and in its extension to the idea of the harmony of the spheres, it generalizes the idea to all nature. The Pythagoreans thought of the heavenly bodies as emitting a hum as they flew through space, the distances between them being such as to form a scale. Earth and moon are a tone apart, moon to Mercury a semitone, Venus to the sun a minor third, Mars to Jupiter and Jupiter to Saturn are each a semitone, and Saturn to the sphere of the 6 stars is a minor third. For the Pythagoreans, as for the others, including Plato, the idea of harmony came to have more than just the mathematical significance of ratios producing consonances. It became a key metaphor in thinking about matters ethical and psychological. Just by itself, however, without further philosophical applications, it represents a notable step. The insights and discoveries of Pythagorean mathematics led not to just the ethical ideas, but to a metaphysics in which reality itself is regarded as constituted by number. Allegedly, the motto above the entrance to a Pythagorean lodge was, "All is number." Think of the dots as atoms. That is not how the Pythagoreans put it, but the connection is a natural one to make, the more so as the structure of material objects. Think of a crystal is informatively describable in terms of geometries. This might not have been what the Pythagoreans meant, for Aristotle reports that they assigned numerical values to certain abstractions, such as justice and marriage. Justice is 4, marriage is 3. The right time is 7. Odd numbers were said to be male, even numbers female. The meaning of such views is unclear, but it is also likely that they thought of the world as consisting structurally of whole numbers and their ratios as their horrified reaction to the discovery of irrational numbers suggests. This is explained as follows. Consider the relationship between the length of a side of a square and the length of the diagonal drawn from one corner of the square to the opposite corner. There is no way of expressing the ratio of the length of the diagonal to the length of a side in integers, whole numbers. Pythagoreans regarded this incommensurability as a ghastly, indeed an evil phenomenon. Just to see what is at stake, consider a square of which each side is 1 meter in length. To determine the length of the diagonal seems easy, for it is the hypotenuse of the right angle triangle it forms with two sides of the square. We know that the square of the diagonal's length is the sum of the squares on the other two sides. It is 2 meters square. For 1 times 1 plus 1 times 1 equals 2. But what is the square root of 2? Well, obviously it is the number which, when multiplied by itself, makes 2. What is that number? It cannot be 1 because 1 times 1 equals 1. It cannot be 2 because 2 times 2 equals 4. It is therefore something in between 2 and 1. But whatever it is, it cannot be expressed as a ratio of two integers. It is not a simple fraction. This is best understood in decimal terms. An irrational number is one whose decimal expansion never either terminates or becomes periodic, repeats regularly. How can nature consist of numbers that misbehave in this way? And that's what the Pythagoreans thought. The discovery of irrational numbers was so traumatic for the Pythagoreans a legend has it that the man who made the discovery, or some of the legends say the man who revealed it after the order's members had been sworn to secrecy about it, namely Hippasos of Metapontum, was punished by being drowned. The discoveries and views of Pythagoreans seem to differ from those of their Ionian predecessors, that it is a relief to find oneself to have borrowed from both Anaximander and Anaximenes. Aristotle relates that the Pythagoreans thought that beyond the heavens there exists a boundless breadth which the world inhales, thereby acquiring a cohesion and order. This is a little reminiscent of Anaximenes, as it is an extension of his concept that the arche is air, and to the idea that darkness is very condensed air. Anaximenes' air is unlimited, like Anaximander's apeiron, and the Pythagoreans make darkness the unlimited and light the limit. Pythagoras is credited with thinking that the earth is a sphere, and later writers also claim that he thought the cosmos is heliocentric, which is why the Copernican heliocentric model of the universe was described as Pythagorean. The idea that the heavens beyond the system of the planets, however arranged, are wheels of burning air which we see through apertures in the underside of the sky, these apertures therefore being the stars, is a conception that the Pythagoreans might have taken from Anaximander. The latter thought there were 3 such wheels, and the Pythagoreans very likely identified the gaps between them with the 3 musical intervals they had discovered, namely the octave, 5th, and 4th, and the music of the spheres. It was the musical discovery that the consonant intervals can be expressed as simple numerical ratios that is the great legacy of Pythagoreanism. The idea of harmonia, harmony, opened a set of conceptual possibilities which proved to be very influential. It suggested that opposites can be brought into harmony or can produce harmonies in their interactions, not least by blending, as when we wet and dry, hot and cold, balance each other or temper each other's excesses. Indeed, the idea of temperament in early medicinal science, the harmonious balancing of the choleric, phlegmatic, melancholic, and sanguine humors, was held to be constitutive of good health. The conception of temperature as a relation between hot and cold, and the ethical doctrine of the mean as the virtuous middle path between vicious extremes. Thus courage is the middle path between cowardice and rashness. All owe themselves in one or another way to the idea of harmonia, Quote, "It is not too much to say," wrote the historian of ancient philosophy, John Burnet, "that Greek philosophy was henceforward to be dominated by the notion of the perfectly tuned string." And that is the lecture on Anaximander, Anaximenes, and Pythagoras, 3 pre-Socratic philosophers who were pertinent for the advancement of the beginnings of ancient science.